So first we are going to define our natural number. Natural numbers. The definition is the numbers used for counting are called natural numbers. For example, when some objects are given and if you have to ask to count the numbers of the objects, and so we always start counting from the number 1. So your natural number starts from the number 1. So 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, dot dot, and it will go up to infinity. Infinity means we can't get the largest natural number, and the smallest natural number is 1. So your smallest natural number is 1 and largest natural number we can't find. So after natural numbers, next will come your whole numbers. So you write the whole the numbers or the whole numbers are the numbers containing 0 along with the natural numbers. So for example, so when natural numbers include 0, then we get starting number will be 0, then the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot dot up to infinity. So these numbers together are called your whole numbers. The smallest whole numbers is your 0, and the largest whole number we can't find. Number 3, integers. Integers definition is the negatives of natural numbers together with the integers, the negatives of natural numbers together with the whole numbers are known as integers. If I show these integers on number line, then you see the left hand side, both side it is going number line, both side extends up to infinity, no stoppage both side. So up to infinity, infinity symbol you put like this is the infinity. Right hand side always positive, and towards left hand side always you take as negative. So this side no stoppage means it will go after infinity towards the left hand side also, and in the middle put here 0, and here put 1, 2, 3, 4, 5, it will go up to infinity. Left hand side, left to 0 all negative, -1, -2, -3, -4, -5, up to go infinity left hand side also. So this portion is here, whole numbers, and this portion here, negatives of natural numbers. The whole family is known as integers. So here, from 1, 2, 3, 4, these are all natural numbers. These are all positive, and from here all negatives, and here all positives, and this 0 is neither negative This 0 is a number which is neither negative nor positive. So 0 is a whole number which you cannot take as positive or which you cannot take as negative. So we have got a definitions of natural numbers, whole numbers, and integers. Now you see here integers, the numbers, all positive natural number 1, 2, 3, 4, 5, 0, and all negatives of natural numbers -1, -2, -3, -4, -5 up to infinity, both side. These are all forming integers. And one thing is that in integers you cannot find any fraction, and in integers you cannot expect any decimal numbers also. In the same way, in the whole numbers also you can't expect any decimal numbers in whole number system, and we can't expect any fraction also in whole number system. And natural numbers also, no decimals number can be natural numbers, and no fractions can be natural numbers. Natural numbers also are always free from decimal numbers and fractions. And also natural numbers cannot be negative, and also whole numbers cannot be negative, and negatives you can find in integers. And also we'll find negatives in the next definition of rational numbers. So now let's start the definition of rational numbers. Number 4, you write rational numbers. The rational word is coming from the word, from ratio we are getting rational. Ratio means when we form ratio we always use two quantities, like quantities or similar quantities to form a ratio. And when we solve problems containing ratio, we always write the ratio in the fractional form a by b. Then this form is known as your rational. So for rational numbers, the numbers should be always in the form of a by b. Okay, so where we should not be confused about these two symbols. A simply indicates your numerator and b simply indicates your denominator. So this type of numbers containing numerator by denominator, these type of numbers are known as rational numbers. So definition, right? The numbers in the form of a by b, comma, where A and B are integers, where numerator and denominator both should be always integers. Numerator should be integers and denominator should also be integers, comma, and B, that means denominator cannot be 0, are known as rational numbers. So rational number means the numbers should be in the form of numerator by denominator. So these type of numbers are known as rational numbers, and both numerator and denominator both should be your integers. Integers, here you have got the numbers, the natures of the numbers of integers. This type of numbers should be your numerator and denominator, maybe positive, maybe negative, no matter. But the denominator b, here taken b, the b denominator cannot be 0, because we can't divide anything by 0. So denominator of any number cannot be 0, that is total will be undefined if you put 0 in the denominator. Numerator can be 0 no matter, but denominator no way can be 0. So we must be very much careful about the denominator. Always denominator cannot be 0. So these type of numbers are known as rational numbers. Now, for example, 2 by 3 minus 3 by 7 minus 5 by 11, 7 by minus 13, 5 minus 3, 0, etc. Okay, these numbers are in the form of a by b, numerator by denominator, so it's a rational. This also a numerator by denominator, so it is a rational number. Both numerator denominator are integers. Here it is a by b format, both numerator and denominator both are integers. Here also the number is in the form of a by b, numerator by denominator, and both a and b, both numerator and denominator are integers. So they are all your rational numbers. But here 5, you see 5 is not in the form of numerator by denominator, it is not in the form of fraction. So how can you expect that this is a rational number? And how you cannot expect that minus 3 is a rational number, because minus 3 is not in the form of a by b. Here 0 also, how can you expect that it's a rational number, because 0 also not in the form of a by b. But then also this 5 minus 3, 0, these numbers can also be taken as rational numbers. So now we'll explain how 5 minus 3, 0, these are all coming under rational numbers. So you see here, now 5 can be written as 5 by 1. As it is not showing the denominator, then we have to take the denominator as 1. So denominator 1 normally ignored. So 5 can be written as 5 by 1, which is coming in the form of a by b. And here we see both a and b are integers. So this is a rational number. Then minus 3 is written as minus 3 by 1. This is coming in the form of a by b. So this is also a rational number. And 0 you can write as 0 by 1. Or you can write 0 by 2. Or 0 by 3. Etc. So here see 0 is written in the form of a by b, numerator by denominator. So 0 is also a rational number. So with the help of diagram, I will show the connection among these natural numbers, whole numbers, integers and rational numbers. First you take this oval as natural numbers. Next oval you take as whole numbers. Next you take as integers, and this is your rational numbers. So you see, natural numbers are contained inside whole numbers, and again whole numbers are contained inside integers, and again integers are contained under rational numbers. For example, you see here, if I add integers dot dot dot, then -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5 dot dot up to infinity. So this portion, you see, these are all natural numbers. Again, natural numbers are contained in whole numbers, and these whole numbers are contained in integers. Again, the integers are contained in rational numbers, because here you see, this is integer -3 written as -3 by 1, -4 integers which can be written as -4 by 1, -5 integer can be written as -5 by 1. So all the integers can be written as rational numbers, and apart from these integers which can be written as rational numbers, we have so many other rational numbers also. So from here it is clear that as all the integers can be written as in the form of rational numbers, so these integers are also contained under your rational numbers. So that is the diagram here, which is showing the connection among all these natural numbers, then whole numbers, integers, and rational numbers. Next we'll start exercise of our textbook, that is exercise 1.1. Let's start. Okay, before starting the exercise, one important part is that in between any two rational numbers there are infinite rational numbers. So write here note, there are infinite rational numbers between two rational numbers. So with the help of number line, show it -infinity and here +infinity, -5, -4, -3, -2, -1, 0, 1, 2, 3. Okay, these are all whole families known as integers. Now these can be taken as rational numbers also. So take the two rational numbers 0 and 1. So in between these two rational numbers 0 and 1, there are infinite rational numbers in between these two. So how will find these infinite rational numbers? The procedure is that between 0 and 1 there is a middle point. For every line segment there is always one middle point. So for this portion from 0 to 1 also we can find one middle point. So this point also represents one number, and this is represented by your number 1/2 midpoint. So how to find the midpoint? For any two numbers a and b, midpoint equal to a plus b by 2. For any two numbers a and b, you can find the middle number by using the formula a plus b by 2. So for 0 and 1 also, to find the middle number you can use this formula, and it will come as half here. So between 0 and 1 I am getting one rational numbers. Again, for this portion from 0 to half, for this portion also must have one middle point, this one. So this middle point will be here. So to find the middle point between 0 and half, again apply the formula between 0 and half. So 1 plus half by 2. So this is your 3 by 2 by 2, that is 3 by 4. So this number will be represented by 3 by 4. So between 0 and 1 I have got two rational numbers. Again for 0 and this portion 3 by 4, I will have one middle point here, I can find it. Again for 0 for this 3 by 4 and this 1 by 2, for this portion also there is one middle point, I can find the number. And from half to 1 there is also middle point, I can find one number here. Like this, for each and every line segment we must have one middle point. Like this, we will, if you continue like this, we will have infinite rational numbers between 0 and 1. We cannot finish it. So that is called a very important part of rational number, that is there are infinite rational numbers between any two rational numbers. So this concept will help to solve the exercise 1.1. Exercise 1.1. Question number 1. Question number 1 is that can 0 can be written as a rational number? Of course yes. 0 can be written as a rational number, or 0 is a rational number. How? Because 0 can be written as 0 by 1 or 0 by 2 or 0 by 3 dot etc. Number 2, you have to write 6 rational numbers. Write 6 rational numbers between 3 and 4. Okay, as you know that between two rational numbers there are infinite rational numbers. So here also between 3 and 4 I have infinite rational numbers, but you are asked only to write 6 rational numbers between 3 and 4. Solution. The first you write the two given rational numbers in the form of a by b. So 3 is written as 3 by 1. So you have to write the numbers in the form of a by b. If it is given, no problem. If it is not given, then write the number in the form of a by b, showing the denominator 1. And next number is your 4. I can write as a by b format, is 4 by 1. So here you see both the numbers are coming written in the form of a by b. After writing the numbers in the form of a by b, then you have to check their denominators must be same. So here you see their denominators are coming same. And if the denominators are not coming same, then you have to make the denominators same by taking the LCM of the two denominators. As here the two denominators are same, so we don't have any problem. So after that, you have to multiply both up and down. This is 4 down 1. This multiply both up and down. Both the numbers will be multiplied up and down. So now how many numbers you have to find between 3 and 4? You have to find the 6 numbers, rational numbers between 3 and 4. So 6. So 1 more than 6 is what? 7. So you have to multiply up and down by 7 or a number more than 7. This is the procedure. As you are asked to write the 6 rational numbers between 3 and 4, so you have to take one more of the number. As it is given as 6, so take one more of 6, that is 7. So you have to multiply the numbers by 7 or more than 7. So when you multiply 7, then it will be 21 by 7, and here you will get multiply up and down by 7, then here 28 by 7. After the multiplication also, you should check the denominators must be always same. So after multiplying, you see denominator same, and check the numerators. In the numerators you are getting sufficient gap, so that I can write 6 numbers between 21 and 28. I have sufficient gap here. So this is a technique to get sufficient gap between the two numbers. We have to multiply. So the numbers will be what? Therefore 6 rational numbers between 3 and 4 are, it is 21, so next will be 22. 22 maintain the denominator 7, then 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. So here you see we have got 6 rational numbers between 3 and 4. It is not necessary that you will also have the same numbers. You may get different numbers also, but the numbers must lie between 3 and 4. These numbers are not unique. It may vary from person to person, but the thing is that the numbers always must lie between 3 and 4. I am getting 7. You can multiply by 10 also up and down. Then you will get different numbers, because there will be a huge gap between the numerator of the two numbers. So it may vary, but technique is that 6 is given, 6 numbers, so you take always one more, 7. So multiply 7 up and down or by the numbers more than 7, then you will get your correct answer. And number 3 is write 5 rational numbers between 3 by 5 and 4 by 5. Here also the denominators are same. Write 5 rational numbers between 3 by 5 and 4 by 5. So this I leave up to you. I will not solve it. You solve this. And next question number 4 will be your true false, and question number 4 also do by yourself, true false, and you have to justify your answer. That means after writing true, you have to give reason why it is true, and also if you write the answer false, then also you have to give reason why the answer is false. That is called writing the answers with justification. So now I will give you one extra question. Write 5 rational numbers between -1 and 2 by 3. Solution: -1 you write as -1 by 1, and 2 by 3. Second one is already in the form of a by b, but first one is -1, which is not in the form of a by b, so I have written in the form of a by b. So after writing first one in the form of a by b, so both are in the form of a by b, but see the denominators are not same. So our target is to make the denominators same. So the first one I can make denominator 3, because the second denominator is 3. I can make the first denominator also 3 by multiplying up and down by 3. It will be -3 by 3. So here you see both denominators are coming same. So now how many numbers you have to write between -1 and 2 by 3? 5. So take one more, that is 6. We multiply both up and down by 6 or by a number more than 6. -18 by 10, and here also multiply by 6. So 12 by 18. So here you are getting gap. Denominators are same. So in between numerator and denominator we are getting gap here. So you can put any 5 rational numbers between these two. So answer will be 5 rational numbers are minus 17 by 18, minus 16 by 18, minus 15 by 18, minus 14 by 18, minus 13 by 18, etc. So I'll this much for today. I'll give some assignments. You please do the assignments, and within 2 days submit to my WhatsApp number. And thank you and have a nice day. Hope you have understood the topic. If any doubt or query, please interact with me over WhatsApp or over phone. So thank you very much.